everyone, in this video I show you why derivative of dy dx sine of x always is equal to cos x. So I want to prove this, or you can say I want to show you why derivative of sine x is always is equal to cos x. So simply I can drive this with the help of differentiability formula. That formula say that if I want to find I want to check differentiability of a function at a point a, which is equal to limit x approach to a f of x minus f of a divided by x minus a. So this is the basic formula of differentiability. But now the thing is, if I want to change variable, suppose I put x is equal to a plus h. Now this my formula converted into limit h approx to 0 f of a plus h minus f of a divided by h. Okay, and now the thing is, this is a derivative at a point a, but I want a formula which is not for a general not for a particular point a, for a general point. So I just replace a by x, so we get f dash x. Where is a, then that a is replaced by x, so we get limit h approx to 0 f of x plus h minus f of a divided by h. Sorry, a is replaced by x, so I write here x. Okay, so this is the formula. Now with the help of this formula I calculate sin x, derivative of sin x is equal to cos x. So let's start. Now the thing is, given that y is equal to fx is equal to sin x, and formula is our f dash x is equal to f of x plus h minus f of x divided by h, and here is our limit that h approx to 0. So now our fx is equal to sin x, so I put value here h approx to 0, f of x plus h means here sin x plus h minus f of x means sin x, and h is indivisible. Now basically we use the formula s minus s is equal to 2cs. So by using that formula we get limit h approx to 0 2 cos x plus h plus x divided by 2 and sin x plus h minus x divided by 2 and whole divided by h. Now these x and this x is 2x. I get limit h approx to 0 2 cos 2x and divided by 2 is x plus h by 2. Here one x is cancel out, what is left behind simply sine, here is 2 not h, here is 2, that's my mistake, so h by 2, and now here is divided by h. Now to balance this I just rewrite 2 here by here. So this is nothing but a general formula. If limit x h approx to 0 and it become obviously 1, so what is left behind, limit h approx to 0 cos x plus h divided by 2. Now this h is approx to 0. It means if I put here 0, what is left behind? Cos x. So this is what I want. So it means that derivative of sin x is nothing but this cos x. So hence proved. Thank you so much.